Two loose threads have been dangling since Module 3, and this lesson ties them both off. Thread 1. When does the clock start for someone who never takes the drug? An initiator has an obvious time 0, the day of their first prescription. But a patient who never initiates has 10 years of eligibility and no moment that says, "Start here." Thread 2. Some strategies cannot even be assigned on day 1. Ask a cardiologist. Should you start a statin within 90 days of discharge? On discharge day, look at Ben, no prescription yet. Which arm is he in? Both. 2 problems and 2 designs to solve them. Thread 1 first. Instead of hunting for the one true time 0, stop hunting and emulate a brand new trial every single month. Watch, in January's trial, everyone eligible that month enrolls. Anna starts a statin in January, so she is in the treated arm. Maria and Tom have not, so they are comparators. February, same idea. March, now Maria starts, so in March's trial she is treated, while Tom is still a comparator. Anna, already on a statin, is simply ineligible for the later trials. Pool every monthly trial together. Notice Maria is a comparator twice and treated once. That is not double counting, it is the design. So when does the non-initiators clock start? Every month they could have started and didn't. Thread 2 is harder because no baseline fact tells you Ben's arm. The clone-sensor-weight design refuses to choose. 3 moves and you already own 2 of them. 1. Clone. At time 0, give every patient 1 copy per strategy, a Ben who initiates within 90 days and a Ben who never does. 2. Censor. Let each clone live exactly as long as the real patient's behavior stays compatible with that clone's strategy. Then cut it. Lesson 12's scissors. 3. Weight. The cutting is informative, so reweight with the censoring weights from Lesson 12. Clone, censor, weight. Watch it work on 2 patients over 1 year, with the grace period ending at day 90. Maria initiates on day 60. Her clone assigned to start within 90 days behaves perfectly. It runs the whole year, uncensored. Her clone assigned to never initiate is cut the instant she fills that prescription, on day 60. Now Ben, who never initiates, his start within 90 days clone is cut at day 91, when the grace period expires with no fill. His never initiate clone runs clean to the end. And here is the subtle part. Before day 60, both of Maria's clones are alive. Her early follow-up and any heart attack in it counts for both arms. Nobody is ever sorted into an arm using their future. Look what just happened to the 2 classic killers. Immortal time bias, gone, structurally. No waiting period is ever credited to a group chosen in hindsight, because both clones own that time until one is cut. Baseline confounding, gone, structurally. The 2 arms start as literally the same people, so there is nothing to balance. But the hard part did not vanish, it moved. All the confounding now lives in one place. Who deviates, and therefore whose clone gets censored, depends on their evolving health. The entire analysis now rests on the censoring-weight model. Clone-sensor-weight is not assumption-free. It is assumption-relocated into the one-place lesson 12 taught you to inspect. So here is the whole Module 4 map, and it is one question. Can you assign each patient to exactly 1 strategy using only baseline data? If yes, single cohort emulation with weighting or the G formula. If the only problem is the comparator's missing birthday, sequential trials. If the strategy itself references time after baseline, grace periods, durations, dynamic rules, clone-sensor-weight. And the 2 designs combine. Many real papers run sequential trials of clone-sensor-weight contrasts. Module 4 is complete. You can now estimate. Module 5 asks the last question. How do you defend all of this when exchangeability is, after everything, still an assumption? See you in Lesson 14.